Welcome back to Stewart Science. Today we're talking about isotopes. Now, isotopes are different versions of the same element. And since they're the same element, they have to have the same number of protons. That's what defines the element. So every atom of a certain element has the same number of protons, but they could have a different number of neutrons. So neutrons, as we talked about in the last video, they don't affect the element, but they do have mass. So if you have an isotope, it means the same element with a different mass because it would have the same number of protons, but a different number of neutrons. So when a scientist will give you an isotope name, they'll give you two pieces of information. They'll give you the element name, and they'll give you the mass number. When you look at a periodic table, you'll see a mass there, but it's an average, so it's a decimal. If they take up all these different isotopes, the different versions of the atoms that each have their own weight, and find the average of all those different isotopes and put that on the periodic table. So for our purposes, when we're looking at specific isotopes, that information really won't be that helpful because we need to know what the mass of individual atoms are, not the overall average of all the atoms put together. So when I give you a isotope name, I will give you two pieces of information, the element name and the mass number. So for example, carbon hyphen 14. That's an isotope name, as opposed to carbon 12. So these are the same element, but they have different mass numbers because they have different numbers of neutrons. So every atom of carbon, if you looked it up on the periodic table, you'd see that it's number 6. So both of these atoms have 6 protons. That symbol P plus just means protons, but they have different numbers of neutrons. So this number right here is the mass number, and both protons and neutrons have mass. So that 14 there says that on this atom of carbon, it has a mass of 14 total. We know out of that 14, 6 of them are protons because every atom of carbon has 6 protons. So to find out how many neutrons it has, you take 14 minus 6. And so for carbon 14, we get 8 neutrons. The N with a little 0 in the superscript means neutrons. Carbon 12 has a mass of 12. And we know out of that 12, you get 6 protons. So that leaves 6 left to be neutrons. I'll give you a slightly harder example. If you looked at aluminum, 27, we'll say, on the periodic table. Well, if you find aluminum on the periodic table, you'll see that it has 13 protons, which means that the remaining 14 are neutrons. You take 27 minus 13 to find the number of neutrons. And you can do this for any atom. If I give you the element name, you look it up and find the atomic number on the periodic table, that's your number of protons, and then you take that and subtract it from your mass number, and you get the number of neutrons. Because protons and neutrons both have mass. So this 27 means that you have 27 total protons and neutrons put together. Out of those, 13 are protons, so the rest are neutrons. You can do this for any atom, big or small. As always, this is Mr. Stewart. Keep learning, no matter what.